Hello everyone, welcome back to this Siemens SINAMICS S210 server drive and motion control series video. And in this video, we will discuss how can we set up the TO technology object to control the SINAMICS S210 server drive. And let's do a briefly review. In the previous video, we set up the IRT communication. And we need to set up the network wheel. Also, we need to set up the top logic wheel. For the IRT communication, we need to set up this top logic wheel, and this top logic need to match 100% match with your real hardware connection. And also, we have a slightly issue on the Telegram 105 at this organization block. Without creating the TO, so we will have this red mark. We will have the issue on this MC Servo, this OB91 configuration. Okay, even you manually set up this 91 by yourself without the TO, after you compile, then the system will delete this OB91. And then you will find you have a right mark on the real-time setting there. If we go to the hardware drive, let's double click. If you quickly recall, so from the hardware drive, this perfect night port and synchronized mode here. Also, we will have this issue on this Telegram configuration at this organization block here. So I temporarily set up this TO. And once we temporarily set up this TO, then you will see the OB91, 92, they automatically created. But in this video, we will starting from the scratch for the TO side. So I will delete this existing one, delete this 2OB, and then let's start over again. So this creating TO, this topic can be an entire topic in this video. Okay, let me firstly delete this TO. Okay, let's assume there's no any TO setup yet. And also, let me delete the OB91 and the 92. Okay, let me delete them. So as we can see, once I delete this TO and the OB91, so here it shows the red again. Okay, let's quickly review. After we set up the perfect night communication and the top logic, then immediately you need to do the next thing is set up the TO. So let's go to this technology object and let's create a new object. And I will create two axes. So the first axis, that's the right drive. So let's click this motion control and click this TO positioning axis. For the servo motion control, basically the positioning axis, 99% you will use this. Okay, so I can manually change a dB number behind. For example, I can change the dB10, okay, and the manual number, or you can click this automatic. I can rename this as a red, okay. So, okay, all right. Once we set up the TO, let's go to the configuration. Meantime, we will see after we set up the TO, so the system automatically create the 91 and the 92, okay, and then let's go to the configuration. Okay, default, the drive and the encoder, they all showing the cross, this red mark. That's because the TO is waiting for us the hardware resource. So let's go to the drive. The diagram is very clear, so we need to assign the real hardware drive to this axis. This axis now is just a logic axis. So if temporarily you do not have any hardware, for the testing purpose, you can select the virtual axis. So it can ignore all the hardware you see here update. Then you can test your logic. Once you have the real hardware, then you can uncheck this virtual axis and then go to the drive, configure the real hardware. So every motion control brands, they all supply this virtual access function. Okay, very convenient for the programming testing purpose. So let's go to drive and let me configure the hardware. So in this case, I have from this perfect night network, I have a red drive and a blue drive. And also you can double check the order number, this article number. Okay, we need to select this red. Okay, here it show gray. That's because we need to select here the drive red and then select this Telegram for this red drive 105. Okay, click OK. And let's wait for a couple seconds. Then the system will automatically search this drive red, drive control Siemens Telegram 105. Okay, and if we click this button, device configuration, So the system will directly jump to this hardware, this start drive, this project. And this time, if we click this drive right, click this Profinet, so we will see at this telegram here, the system automatically assign this MC Servo, this OB91, and also this process image here. We will see this process image. And if we go to the asynchronous mode here, this is the time clock. Okay, everything looks good. And go back to the configuration again. So after you configure the drive, the encoder is also automatically configured. And as we can see here, in some cases, depends on your application. Encoder for the server drive, you may have two encoder. Typically, we have one. That one encoder basically mounted behind the drive, right? So they come with the server motor. But some cases, you may have another external encoder that represent from the load side. Then you can check this encoder too. But keep in mind, if you are using two encoders, then your system, basically the telegram, you have to use telegram 106 because 106 telegram includes two encoders. Okay, then if we go back to the hardware, go from here and go to the Profinet, this telegram here, then you need to pick the 106. However, the SINAMICS S210 doesn't support the telegram 106. So somehow you need to be very carefully. So after all, the SINAMICS 210 that support very typical and standard application. That two encoders application basically is high-end. So you can use the SINAMICS 120 server drive. Okay. Let's go back to the STO configuration, the encoder. And from the encoder, we also need to reveal this selection here. The system automatically identify the encoder that is the absolute encoder. Okay, so that depends on this device configuration here. And we can click this encoder, and when we set up this encoder, the system identify the encoder already. That's why when we set up TO, once we select this drive, this station, then the encoder and the drive automatically show up here. Okay, here encoder. And then we can double check the data exchange. So it's using 105. Okay. And temporarily, we leave this torque data off. I will use another video to activate this torque data so we can use the Telegram 750. We can add on the Telegram 750 to show how can we use the torque limitation, torque reduction. Okay. And for the encoder 1, we're also using this standard Telegram 105. And for the encoder, we will see it comes with this XIST and SIST2, okay, because this is an absolute encoder. And then let's go to the motion control portion, extended parameter. So firstly, this mechanics, this is basically the most important other than the hardware in the system. So here you will see how your system mounted the encoder. Most of cases for the server drive, the encoder represent the end of the motor. So we will see this encoder mounted type is on the motor shaft. This is basically used for the calculate. For example, if you have a lead screw here, maybe turn spins from the motor, turn revolutions from the motor, you just forward 1 millimeter. Then somehow you have a calculation there. So this can tell us, so encoder read from the motor shaft directly. And then the load, you can calculate the load here. Okay. For example, from the gearbox, so if this ratio is 10, so 10 revolutions, then the lead screw just spin 1 revolution. Then you can see the numbers of the motor revolution you can type in. So gearbox is a 10 revolution. Then they represent 1 revolution from the load. And if you are using the lead screw here, then you can configure 1 spin, 1 revolution from the lead screw, what the distance is traveled from the lead screw pitch. Okay, 1 rotation, how many millimeters. So this is the calculation behind. Then once you set up here, from the access control, then you can focus on the millimeter. So in this case, as you remember from this demo, I'm using this rotary, this disc to test. So basically, if I set the degree, it will quite straightforward. So we will see, for example, when I control 360, then it can spin 1 revolution, right? So I can set this entire scenario as the rotary application. Then let's go back to the basic. So the basic here, default, that's the linear. And we can configure the millimeter and the units. We can shift to the rotary. So it can automatically change to the degrees and the rates. Okay, and torque, that is a new meter. Okay, once I change this rotary, if I go back to this mechanics, we will see the encoder, then it doesn't have that pitch setting anymore. But it will show us if we have a gearbox somewhere, we can set the motor revolutions and the load revolutions. Basically, for example, the typical case from the gearbox, we can use the ratio 20/1 or 40/1. Then that time we can set 40 revolutions from the motor, then 1 revolution from the load. Okay, but in this case, from my application, my disk directly mounted on the motor, so I can set 1/1. Okay, 1/1. Some cases you may feel confused for this revolution calculation, this ratio. So the best way, I personally recommend you can set 1:1, even for the linear. So once you set 1:1, you can spin the motor 10 revolutions. Then you can directly measure what the actual distance traveled from the load or actual degrees spin from the load. Then you can roughly know when you set up 10 revolutions, 360, 3600 degree, right, from the motor spin, then what the real distance or real angles spin or moved from your load. Then you can immediately know the internal ratio calculation from this axis, from this mechanical things. And if you find the motor got a backward, then you can turn on this invert encoder direction. So from my personal experience, once you try to forward your drive and you find your load actually travel backward, then basically most of cases you need to check the invert encoder and in the meantime also invert your drive direction. Because usually the encoder come together with the motor when you order the servo motor, right? So the servo motor and the drive, they always come together the same direction. But your load usually have a backward direction. Then you need to invert your encoder, also invert your drive. Okay, keep in mind this. So that invert is very simple, but basically they will come together to invert at the same time, active at the same time. Okay, the mechanicals. So we will set 1:1, this ratio. And then let's go to the dynamic default. Dynamic default here is also important. So this somehow correlated with your motion control command. So by default, some motion control command, for example, acceleration, deceleration, jerk value, the default function block setting will be the -1. When it leaves as a default, then the default value will come from here. So we better set a normal, a regular acceleration, deceleration for this system to make sure the system can basically working properly. So you can set a default velocity, acceleration, and deceleration. Okay, for example, the acceleration, deceleration here, I can set a smaller, okay? So let it acceleration, deceleration won't be too aggressive. Basically, typical, you set a velocity and you can times 10 times for the acceleration. The jerk, you can also set 10 times on the acceleration. But this 10 times based on the load is very light. If you definitely have a heavy load, then you can set 2 or 3 times on the velocity for the acceleration. And the jerk can be set 2 or 3 times based on the acceleration, deceleration. So this is the default values. Then let's go to the emergency stop. The emergency stop can control the drive how fast it can stop after we press the emergency stop or once we shut down the power. Usually we can leave as a default or depends on your load inertia. So if your load momentary inertia is too high, so somehow you can increase this ramp down time. For example, bump up to 0.5 seconds. Because if the motor stops too quick, then maybe your shaft will be broken, right? And this is deceleration. For example, we can leave 360 and the time 100. So this speed. So this is totally application oriented. Okay, an emergency stop. Then let's go to the limits. The limits by default, I won't recommend you turn on them at the early beginning, because once you enable them, maybe your drive cannot forward or go backward, then it takes your time to troubleshoot. Once you can spin the motor while the TO, then after that you can come back and set those limits. So let's quickly review. Firstly, this is the position limits. That's very clear. Usually if you're traveling, have a forward or backward, probably you have two sensors at the forward and the backward side, then you can enable them. And also you can configure the input address, so the TO can read those physical input. So you can configure the input, give a tag name, variable name, then you can configure that here. Also you can configure if the sensor on means getting at the end, or off means getting at the end. If that's off means getting at the end, then you can configure the low level. Okay. Also here you can configure the software limit switch. So at the early beginning, if you do want to protect your system, so probably you can enable this software limits. And keep in mind, after you enable this, don't forget home your access first. Make sure your access moving just within this software limits. Okay. Then let's go to the dynamic limits. This screen looks like the dynamic default screen. You will see these two screens very similar. So they are playing different role. The dynamic default, that means once we drag any function block, the MC motion control function block, those acceleration velocity, they will be used as a default value. But this dynamic limits will be basically protect if some cases your command set too high on the acceleration or velocity. This gives some protection for your access. Keep in mind this unit. So those units associated with your basic parameter, this rotary, this axis type, and this unit. Okay, and keep in mind this dynamic. Sometimes when you use the function block control the axis, you find the axis cannot go higher anymore. That may be because your maximum acceleration or maximum velocity that got a limit at here. So I would recommend at the end of the project you can review this dynamic setting to set the application maximum velocity and somehow protect the system. Okay. And then let's go to the torque limits. So the torque limits, this point to if the torque represent the load side or the motor side. Basically, I would recommend you can set as the motor side. The motor side will be the better because somehow if you have the gear ratio here, maybe the calculation will go wrong. After all, the torque value directly represents the current from the motor. So whatever the gearbox outside or whatever this ratio calculation outside, if you select the motor side, the effective, the torque limits, we just point to the motor. Even you change the gearbox, it doesn't matter. The torque limits always represent the motor. Personally, I would recommend left as on the motor side. But currently we haven't enabled the torque yet. So this value doesn't matter here so far. And for this position related monitoring, I would recommend you can click here, just leave the mouse here, then go to this configuration torque limit setting. So you can read the details from this help. Okay, and read these details at here. Okay, as we can see for the linear side, so basically the default leave as on motor side. And for the rotary, so it can select these two options. But I would still recommend on the motor side, we set this. Okay, so as we can see here, this limits value will be effective while we are using this MC torque limiting. We are now calling this torque limiting. So that's why this setting, so now it's not working. So it doesn't matter. The motor will try its best, do its maximum torque while it's spinning, while it's doing the load. Alright, regarding this fixed stop monitoring, this is used to move a motor to a fixed stop at a specific torque. At that time, we do not want to deliver any fault. So we need to set this following arrow and this fixed stop monitor this range. And usually this will be used for active access homing. So the drive can go home till reach the end, reach the fixed stop, and at that time still hold this torque. So this motion, this whole mechanical things can stay at this fixed stop. So when the stop is reached, the specific torque is still built up and remains is applied. Okay, and then let's go to the homing. So homing is a big topic. Typically, the homing has a couple ways to home to zero the encoder. So easiest way is a passive homing. The basic idea is, so you can use the sensor or you can use the trigger command. That means you can firstly park your drive to a position, and then you set the current position to a value. That set command trigger can come from the zero mark of the encoder or an external sensor, the home sensor. And also you can involve them together, use the reference cam, the home sensor, and the zero mark together to directly set a value. This is the passive. Passive means the drive is stopped there, is just waiting for a trigger to set a position value to this axis. Okay, this is the passive. And the complex way, this is active home. So from this diagram, it's much clearer. So you can control the travel direction, whatever go negative or positive, you will see the drive travel. So for example, if I'm using this positive as an example, so that means maybe the drive stop here. Then when you trigger this active home, then the drive will travel back. That's why I call it active. It's traveling back till it see a reference sensor. The most complex way, that's the use the reference cam and the zero mark. But once you understand this, it will much easier to understand the zero mark or the home sensor only. So let's look at this. This is also the more accurate way. So let's look at this diagram. Either you can from the negative direction or positive direction. Let's use this application as an example. The motor is at here. When we trigger the active homing from the home command, definitely you need to select the mode. The mode will be the active homing and this reference cam and the zero mark, this application, these options. Then the drive will active move towards to the home sensor direction. Definitely you need to assign the positive or negative. That's why we have two options here. Then the drive will traveling back towards to the sensor till it touch on the home sensor here. Okay, this is the home sensor. This is the cam, the reference cam. That's the home sensor. And once it touch on the home sensor, it immediately slow down because the rest of the travel, the motor is still traveling very slow basically. Then it's searching the encoder zero mark from the encoder. And once it see the encoder zero mark, it record that position. And maybe the drive still need a short distance, just maybe very short to stop. But at the moment, the drive internally record that position already. After it totally stop, then the drive can move backward a little bit, back to this real record position from this zero mark. Then meantime, it will zero or set a value to this position. This is the real home position. Using this way, because we have this cam reference sensor, this home sensor, see this position ahead to preview this position. And also use this internal zero mark of the encoder as a real zero position. So this way can home the axis very accurately. The only things you need to take care is somehow you need to trade off the speed, searching speed, and this offset value. Because sometimes you may find to accurately find out the position, then your travel will be very slow. Travel very slow, that will cause this homing sequence very long. So you need to balance that. But basically, if you are using the absolute encoder, homing the machine, you only need do one time, right? And if you are using the incremental encoder, the only thing you need to do the homing machine, that is the cycle power. After the cycle power, you only need to do one time. So even that slow, that's still worth to do this accurately. Here, I would recommend set slow approaching velocity, so to make sure all the home position is consistent and very accurate. Okay, so this is active home. Okay, and then let's go to the positioning monitor. Here, actually, this area is very important. Some cases when you set up the motion control system, and for the positioning control, we will find a typical fault, that's the falling error. So the falling error basically caused by this, especially from this falling error here. Default, they all enabled. But if your axis configuration has something wrong, for example, the direction backward or the ratio is not accurate enough, calculated wrong, then 100% you will get an error from this falling error monitoring. So I would recommend at the early beginning, you can turn off this following arrow. Also turn off the positioning monitoring or set this window basically very high. Okay. Once you feel your direction correct and all your calculation roughly that travel distance makes sense, then you can turn on those following arrow. So basically following arrow can use to verify, to validate if your positioning control accurately enough or validate if your mechanical got broken. So I highly recommend you can activate this following monitoring after you test everything. But early beginning, you can disable this monitoring. And same thing for the positioning monitoring. So you can see this is tolerant. So once you fired up the set point, so how fast this actual value position will follow your command. So you can set this position window. This also monitor the mechanical performance. So this is the monitor tolerant time and do well time to check out when the drive stop to see this monitoring. And then same thing for the standstill. So we will see how to judge if the system totally stopped. So this is a small window to judge if the motor totally stopped. So make sure this window set basically narrow. Don't be too wide. So some cases, if you are using the standstill, the bool from the access status to judge if the access stopped. So this window is very important. If you set it too high, maybe your motor still spinning, still moving slowly, then you judge as a standstill. And then maybe you are using the standstill signal to fire the tool, come down to press or do some mechanical tooling sequence, then they may crash because the drive still slows moving. Okay, so the standstill, this window is also very important. Okay, so positioning monitoring. Then the last thing is closed loop control loop. And the most important value is this, the positioning gain. So there's one keyword in this screen that is the dynamic servo control, DIC function I mentioned ago. So default, if you are using Siemens S120, S110, and this S210 servo drive, this medium and high-end servo drive, they all come with this DIC function. And they all default using the Telegram 105. That means once we enable, default that's enabled, once we enable this closed loop will be located at the drive side. The PLC only sent the positioning command and doing somehow the monitor way using those TO settings. But the closed loop gain actually located on the drive side. This can make the positioning loop, the bandwidth very high and the reaction time could be very fast. After all, this is a drive internally, right? So I highly recommend you turn on this. So you will see the drive Telegram 56, 105, and 106 support the DIC function. But for some cases, especially some cases, you cannot use the IRT communication like the topic I introduced from the previous video. You cannot use the IRT communication. Then you can use the perfect RT without configuring the top logic view. Then you can use the PLC running as the closed loop. So we will see once I select this, the gain located at the controller PLC side. Okay, the PLC will run this closed loop. So using this way, you can use the Telegram 3. The Telegram 3 do not need the IRT communication. But most of cases, again, so I will recommend you are using the DIC function. And again, you can set the parameter for the gain for the drive. Okay, and you can tune the gain for your positioning closed loop performance. Okay, this is the control loop. The only important parameter is here. Okay, and the last thing is the actual value. Basically set the filters for your encoder, and default it doesn't have any filter setting here. If you do find your encoder signal that fluctuation too high, then you can somehow increase a little bit of filter time here. But increasing the filter time will make your positioning performance decrease dramatically. So this need to be trade off. You need to be very carefully for this. Okay, so again, basically at the early beginning, you do not need to change anything. You only maybe change is disable those monitoring to somehow prevent you got a lot of errors from your system, you can disable the following errors for that. And then we can power up the access. Okay, so this is the red master. And then let me create the blue, just to quickly review and quickly go through those settings again. So I will create the second one. So the second one, again, in future, I will use the second blue as the slave, as a synchronized access, and use the right access as a master. So I will create a synchronized access. And manually, I will select 11. And here, I will name that blue. And in your application, if you do not need any synchronization, all the access control, they are doing the positioning control only. So you can also select this positioning access. Okay. So in this case, I'm selecting this and click OK. All right, let's go to the drive and select the blue drive. Blue drive, select this 105. Okay. All right, encoder, quickly go through encoder. This is absolute encoder, okay, from this Telegram 105. Okay. Encoder automatically identified where the drive click. And then go to the mechanics. So again, I will assign this axis as a rotary also because this is a disk. Okay, apply the change. Okay, degree and new meter unit from the torque. Okay, then go back to the mechanics and assign this motor shaft. Okay, motor shaft, and I will set 1 to 1. Okay, and dynamic setting, I will leave all those things as a default, but I will quickly go through. Okay. Limits. Okay, disable the limits. Hardware and software limits, disable them. And the dynamic leave as a default here. Torque limits on the motor side. Okay, and fixed stop detection leave as a default. Active monitoring, okay, default. Passive, default. And the positioning monitoring, so somehow I can disable the monitoring arrow. Okay, we can disable that. Okay, stand still, okay, 180 degrees and in this short period. So I can set, for example, 0.5 seconds. Okay, and control loop leaves 10 as a default. Then we can test the positioning control performance and actual value, so we can leave as default. Okay, that's it. So we config the TO for the blue and the red. Then now I can save and compile. I will temporarily park this video here, and I will use the next video to show the online testing using the TO technology object to move these two axes. Also, I will show the motor running videos. Okay, there's no any error showing here. Then we can download all those configuration program, and then we can use the TO to move the axis. See you in the next video, the online testing. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.